In this lecture, I will discuss the numerical solution of SIR model by Euler method in Excel. First, I will discuss Euler method for SIR model and then solution in Excel. This is a picture taken from Excel. In Excel, we will be able to find the numerical values of the functions SI and R representing susceptible, infected, and removed population, as well as the graphs of susceptible population, infected population, and remote population. The example that I will solve in this lecture is taken from Numerical Analysis by Burden and Ferris, exercise 5.5 question 6, in which the infection rate beta and the removal rate gamma are given. The total population is also given 100,000. Initially, the susceptible population is 99,000, infected population is 1,000, and remote population is 0. And according to the problem, we have to find the population of susceptibles, infected, and removed after 30 days. We will discuss the same for t greater than 30 as well. For the given values of beta and gamma, we can find the basic reproduction number or not, which is greater than 1. So an epidemic occurs in this case. Euler method for system of 3 ODEs. If we have a system of 3 ODEs with the given interval for time t, step size, and initial conditions, so the numerical solution by Euler method are xi plus 1 is equal to xi plus h times f1. Similarly, yi plus 1 and zi plus 1 can be written, where xi is the value of x at ti. Xi plus 1 is the value of x at ti plus 1, where ti is t naught plus ih and ti plus 1 is equal to ti plus h. This means that t naught, t1, t2 and so on are equally spaced. To write the solution by Euler method for SIR model, let S naught is equal to S of T naught. The value of S of T at T is equal to T naught. Similarly, I naught is equal to I of T naught and R naught is equal to R of T naught. Please note that R naught is also used for the basic reproduction number, but here it is not the basic reproduction number. To avoid the confusion, one can also use some other notation like x naught, y naught, and z naught. So the numerical solution by Euler method for SIR model are Si plus 1 is equal to Si minus h times beta Si I sub I by n. Similarly, the other two equations. Or if we write S of Ti for Si and S of Ti plus h for Si plus 1, these are the solutions for SIR model by Euler method. Further, the first iteration can also be written as S of T1 is equal to S of T naught minus h times beta S of T naught and so on. More conveniently, let T naught is 0, T1 is 1, T2 is 2 and so on, so that the first iteration of Euler method for SIR model is S of 1 is equal to S of 0 minus h beta times S of 0 I of 0 divided by n. Similarly, the other two solutions. And the second iteration will be S of 2 is equal to S of 1 minus h beta S of 1 I of 1 and so on. So we have to remember this slide especially for the Excel. Now to solve SIR model in Excel, this is the solution that I have already obtained in the Excel, but I want to do it from the start so that you can understand each step. Let us open a new Excel file and control all. Let me increase the font size for all, and let us increase this one and up to 36 as I did in the file. Control A, all borders. Now let us write TI here. Select I, right click, format cells, subscript. This is how to write TI. Now let us write S of TI. Again TI and select I, right click, copy and paste this second column here, and also here, but now replace S by I and S by R. Similarly here, let us write S plus I plus R. Just bold it, and here I will use constants. Let us decrease its font size, and remember that I will use $sign whenever I use these values in the formulas to be defined. So here I am writing the value of n, the value of h, here the value of beta. This is, sorry, this one, not this one, this small beta. And the value of gamma. Here I will write R naught. Let us also increase the font size of these. But please remember that the values of these constants will be in the next cell. For example, 100,000. Comma notation, counting. H is equal to 1. H is equal to 1. The value of R naught in this example is 2. The value of gamma is 1 over 10 or 0.1. To write 1 over 10 in Excel, write 0 space 1 by 10 and enter. Note that the value of beta is also given in this example, which is 0.2. But in general cases, in some other example, if beta is not given and gamma and R naught are given, so we have to write this is a product of gamma F9 steric F11. So this will give us the value of beta. Now when T naught is equal to 0, let us also write these in the center. If T naught is equal to 0, The removed population is also 0. The infected population is 1000. And the susceptible population is 99,000. We can directly write 99,000 as well. But I want to write here the value of n is an F3, column F, row 3, minus this. So it is also 99,000. Please note that the sum of I, R, and S must be equal to the total population because the total population is fixed. And B2 plus C2 plus initially it must also be equal to 100,000. Now T naught is equal to 0 and T1 is equal to, suppose H is equal to 1, so T1 will be equal to 1. But if H is equal to 2, T1 will be equal to 2. Let us write it, define it also. T1 is equal to T naught plus H. But remember, when we use H in the formula, we have to write this dollar sign, because if H is some other value other than 1, for example, H is equal to 2, we will have 0, 2, 4, 6, and so on. If H is equal to 3, we will have 0, 3, 6, 9, and so on. But in this example, let us write H is equal to 1 only. Now, what will be the formula for S of 1? Again, have a look at the Excel. S of 1 will be equal to S of 0 minus H beta S of 0 I of 0 divided by N. So we have to put this formula in the Excel. Equal to S of 1 is equal to S of 0 minus H, but remember dollar sign because H is constant. For multiply, use steric. Now multiply beta and again dollar signs. Steric H multiplied by beta multiplied by S of 0 multiplied by I of 0 whole divided by N. And for N again use dollar sign. So this is the susceptible population after 1 day. Initially when T is equal to 0, 99,000 people are susceptible. After 1 day, 98,802 people are susceptible. Similarly, to find the infected population after 1 day, let us repeat the same as equal to, again, I of 0 minus H with dollar signs multiplied by beta, again dollar signs, multiplied by S of 0 multiplied by I of 0 divided by N, and we have to use dollar sign here as well. Minus H times gamma times I of 0. So here minus H is again this with dollar sign. The value of gamma dollar sign multiplied by I of 0. Similarly, R of 1 is equal to R of 0 plus H gamma I of 0 plus H dollar sign plus H steric gamma dollar sign again steric I of 0, and here sorry, in this formula I forgot to write plus here. Now it is all right. Let us apply this to the remaining cells up to 30 days. This is up to 28. Let us apply this notation here. Now after 30 days, the susceptible population is 7,500, 776. The infected population is 10,940, and the removed population, which include the people who have recovered from the disease or the people who have died, and this population is 13,282. And as we know that the total population is fixed, so the total number is 100,000. We can further apply it to the remaining cells. For example, we can do it up to 150 days. We can also do this so that we got whole numbers. Now let us sketch the graph of S, I, and R. So select all these values, all these 4 columns, and click Insert, Charts, and this one is okay. So let us cut it from here and paste it here. We can also edit it. SIR model solution. We can also edit it. Series 1 is, for example, susceptible, and series 2 is infected population. Series 3 is remote population. S, I, and R. We can also change these colors. For example, select series S and let its color be orange. Series I infected, let its color be red. And for the series R, let us choose green color. So these are the curves for susceptible, infected, and remote population. We can also use the same colors here. Orange for susceptible, red for infected, and green for remote population. And let us use blue color for this. The graph of SIR model shows that if we look at the curve of the infected population, initially it increases, but after some day, for example 45 or 46, it is the peak, and after that it decreases. Similarly, the susceptible population curve is decreasing, and after some time it is flattened. Whenever the infected curve is also flattened, and we can see that the removed population curve is increasing, and after some time all the curves are flattened. We can also compare the values. For example, look at the 45th day, 16,234. Let us compare it with the numerical values. Day 45, susceptible population is 49,261, infected population is 16,234, and the remote population, which include the people who have recovered from the disease or those who have passed away, and this population is 34,505, such that the total population is fixed 100,000. Similarly, we can compare the other numerical values with the graph. And please note one thing more, that if we change, for example, R naught is equal to 3, it is the basic reproduction number, which means that the number of secondary infections caused by one infected person. So in this case, this will be the graph, and we can also see the numerical values. We can compare this with the numerical values as well. Or if R naught is 4, for example. Similarly, if we use other values of H, for example, we use 2. These are all factors that can change the solution. You can practice, you can find your own SIR model. You can construct by using these techniques. I hope you like this video. Thank you for watching. And in the next lecture, I will discuss SIR model for the spread of COVID-19 in Pakistan or any other country or any big city